Hi everyone, I'm Mohammed, and in this video we'll be developing an AI agent for news fact checking. So here's the scenario. Imagine we have some news or some statement and we want to check whether it's true or not, or maybe we want to verify it. So we'll be developing an AI agent that goes online and searches for various resources to verify our query. In this video, we'll be using AutoGen and MCP servers for our agentic development. And in the end, we'll develop a web application, a simple user interface for our agent. So without further ado, let's start. Okay, so just like my previous videos, we'll be developing this project in two parts. In the first part, we'll develop the AI agent and provide the MCP server for that to search over the internet. And in the second part, we'll develop the UI or the web application with Streamlit. So for the AI agent, we'll use AutoGen just like my previous videos. So let's create an agent.py. In order to build the agent, we need to import the AssistantAgent class from AutoGen. From AutoGen agent chat.agents, import AssistantAgent. And as you know, we need to provide an LLM for this assistant agent. It uses an underlying LLM. Just like the previous videos, I'll be using an OpenAI LLM, for example, GPT4.1. Although I had a comment for my previous video from Merdad, I guess, he was suggesting to use other LLMs such as Grok. I totally agree with that, but right now I don't have their APIs. But I'll make sure to get their APIs for my subsequent videos. So for now, I need to import OpenAI models in AutoGen from AutoGen extensions.models.openai. Import OpenAI chat completion client. And since AutoGen uses async IO, we also need to import that as well. So I'll make a coroutine. A main coroutine, and I need to provide the LLM. So I'll call it model equals OpenAI chat completion client. The model will be GPT4.0, and I need to provide the API key. So I have my API key in API underline OpenAI.text. I just need to read that. Open API underline OpenAI .text .read .strip. .read reads the entire file, and .strip makes sure there's no extra space in the end. So right now we have the LLM, and here I can define the agent. It's an assistant agent. I need to name it. Let's go with agent. And I can define a system message for the agent to define its role and its instructions. So in order to better organize my stuff in my script, I'll write down the system message in a separate text file. Let's create an agent.text. So you are a helpful assistant for news fact checking. You will get some news or a statement, and you need to check online about it and generate a report. And well, I can stop here, and what happens is that the LLM will mostly decide what to do next for me, but that way my program will be somehow more random, and I don't like that, honestly. So I prefer that my agent be more deterministic, be more controllable. So I will specify the steps it needs to do for each query, and then I'll let it do each step. So I can say once you get the input, you need to generate a step-by-step plan as your first message, like the following. So here's an example. Here's my step-by-step plan, and then we have step 1. In step 1, I wanna just decide on some search keywords and search terms. So I would say decide on search terms based on this statement. On the second step, I want to decide on what resources to check. So decide on the sources to check for information, and I can say at least 5 sources. In step 3, I would like to search each of these sources one by one to get some information about the query. So search for the relevant information using the search terms and sources. Or maybe I can forget about the search terms here. Search for the relevant information from the sources one by one. Yeah, something like this. And 4, summarize the findings and generate a markdown report. Okay. And then you need to follow the plan. In each step, you should clearly state the current status and what you're gonna do next. Yeah. And I also need to somehow, make a signal for my agent. Actually, the agent needs to signal the end of the conversation or the end of its operation. So I can either decide on a specific expression, such as terminate with capital letters, or maybe I can provide a function to the agent and ask the agent to call the function once it wants to finish the conversation or the operations. So once you've finished the report, you need to call, I will develop a terminate function, the terminate function, to indicate that the task is complete. Yeah. Okay. This seems okay. Let's see how it works. So for the system message, I will read this agent.text, agent.text.read.strip, just like how I did this for the models API key. And I need to specify the model client. It will be model. And now one of the most important steps I need to take is that I need to provide the MCP server for web search, because right now the agent doesn't have any tool, doesn't have any means to search over the internet. So I need to provide some tool for that so that it can search over the net. So there are a bunch of tools and MCP servers for fetching a URL or searching online. The one I'll be using today is Tavily. Tavily is a tool or a service that lets you search over the internet and look for news online. The main reason I'll be using it is that I've used it about a month ago in a project and it worked really well. So that's why I'll be using it today. And it's really cheap, and I guess for the first month or something like that, it will be free if you just register. Or even better than that, if you're a student, you can send them an email and they will send you a free API for 4 months, I guess. So let me show you Tavily. Yes, that's it. Yes, as you see, we can take a look at these features. So it's a search API. And other than their MCP server, you can even use its Python library. It's this easy. You can just create a Tavily client with your API key and then search for whatever you want. And yeah, that's it. But we're not use their Python module today. Instead, we'll be using their MCP server. I can search for Tavily MCP server. Let's go to their GitHub. Yeah. Okay, this is their MCP server. The thing we should look for is this one, the command we need to use and the arguments. And also, do we need environment? This seems strange. Oh, it has provided the API key here as a comment, as an argument, but let's see if it has a better way of doing this. Yeah, it has used it as an argument. Yeah, let's stick to this approach. So this is what I need to do. From AutoGen x.tools.mcp, I'll import MCP server tools and stdio server params. And I need to create the parameters for the stdio server. So let's call it params. I need to specify the comment. The comment will be npx and the arguments. So this is the arguments I need for that. And of course, I need to replace my API key here. So for this one, I can format it. And instead of your API key, I can say, yes, open API tavily.text.read.strip. And I believe that's it. And I need to get its tools. Let's say MCP tools. I need to await MCP server tools, and the server params will be params. Okay. Now I can easily provide this MCP tools as an argument to my agent. So tools will be MCP tools. And other than this, I need to make a terminate function. It doesn't need to do anything. It will just be called by the agent to signal that the operation has been done. So I can just provide a docstring documentation for that. Terminate the conversation or operation by the agent. Yeah. And it doesn't need to do anything, just pass. And I can also provide that to the tools. So it will be MCP tools plus terminate. And just for better organizing it, let's put it inside parentheses. And I believe that's it. So now I can run this agent. I can assign it a task and see if it works or not. But better than that, if I run it right now, if I run the agent, as we've seen in previous videos, it will just do one step or generate one message and one tool call. That is certainly not enough. We need to do several steps with the agent. So I need to make a team out of this agent, a team of just this single agent, so that, inside AutoGen, if I want to do this in several steps, in multiple steps, I need to make a team. The agent cannot run in multiple steps on its own. So I need to import a team. And for this usage, a RoundRobinGroupChat is what I'm looking for. So from AutoGen agent_chat.teams, import RoundRobinGroupChat. And this will be my team. It will be a RoundRobinGroupChat. I need to specify the participants. It will just be the agent and the maximum number of turns. Let's say 10 turns at most. And I can also specify a termination condition. So I need to import the function called termination condition from AutoGen as well. So from AutoGen agent_chat.conditions, import function called termination. I can create an object, function called termination. What is the function name? The name is terminate. Yes. Okay. Now I can specify a task for the agent. For example, is Lionel Messi 25 years old? I wish you were now. Okay. And now I can run the agent. So I can say, as I've mentioned this in my previous videos, I can easily say result equals await team.run and provide a task. And this works perfect. The problem is that we should wait until all of the messages are there, and then maybe we should wait for a minute or two, and then we'll have all of the history and all of the operations done by the agent all at once. But obviously I don't want to do that. This is not a very good or the best user experience possible. I want to show each message once it's been generated and I have it. So instead of doing it this way, I can say we have a runStream method. It's actually a coroutine or an async generator. It will yield every message once it's been generated, and I can iterate over it and display every message once I have it. So async for message in team.runStream, and the task will be task. So for those who are Python geeks, the question, do you think I can just do it this way? The answer is I can't, otherwise I wouldn't have asked this question. But why is that? You can go and find about it. I should always use, specify the argument this way. Task equals task. And I'll print a bunch of dashes just to make sure that different messages are separate, times 20, let's say. And then I'll print the message. So let's create an event loop, async io.run, and I will run the main coroutine here. So Python main.py, agent.py, let's see. Okay, you see the MCP server is being built. Yeah, we have some function calls. Let's see. Okay, so these are just for the MCP server. This is my first message. Is Lionel Messi 25 years old? And then here's the first message from the agent. Here's my step-by-step plan. 1, decide on search terms based on statement. Lionel Messi age, 2023. Oh, maybe this is the date in which GPT-4.0 was trained or was pre-trained. To decide on the sources to check for information, Wikipedia, BBC Sport, ESPN. This makes sense. These are trustworthy sources. And 3, search for the relevant information from the sources one by one. And 4, summarize the findings and generate a markdown report. Now, let's proceed with the plan. I'll start with the first step. Okay. But it is looking for the tools already. And let's see which tool has it used. So it has used, what is the name of the tool? Yeah, Tavily Search. Lionel Messi age 2023. Max results 5. Search depth basic. Topic general. Okay. And also other searches. For example, in this one, it has called several tools at the same time in parallel because that's possible. Our searches are independent. So, and now we have Wikipedia, for example, in our domains, or we have ESPN.com or, other domains. This is fine, but honestly, I don't want to do it this way, but let's see what happens next. I have another tool call. Okay. And then I have terminate. Yeah. Obviously, we have a problem. So I forgot to set the reflect on tool use flag to true. So we have this argument reflect on tool use. It makes sure that once the agent has called the tool and gets the result back, it should reflect on the result. It should process it and generate some text about it. So having this flag set as true, I can generate something more meaningful. Although you see, it has used the tool correctly. It has searched for the right terms and in right domains, but still I need my report in the end. Okay. Again, this is the user's message. This is the agent's plan. And okay, this is the next message. Current status, step 1, decide on search terms. I will use the following search terms to verify Lionel Messi's age. Okay. And since it's looking for the age at 2023, maybe I can be more specific in my task. Is Lionel Messi 25 years old on 2025? This will be better. Okay, so this was step 1. It has decided on search terms. And step 2, decide on sources. And these are the sources. Wikipedia, ESPN, BBC Sport, official FC Barcelona or Inter Miami CF. Fair enough. And I will now proceed to step 3 to search for the relevant information from the sources one by one. Okay. Now it has used this tool, Tavily Search, searching in news, And as we said, one by one, now it has listened to us. I don't know why it didn't listen in the last execution, but of course we need to change our prompt so that we make sure it always uses, searches one by one. And okay, for example, Lionel Messi age 2023, another function called Lionel Messi current age, and so on and so forth. Okay. Then here's our results. And as you see, the results are lengthy documents because, it has searched an HTML page. Although it is converting the HTML format to Markdown, this is what Tavily does. But yet we have lots of text and lots of context. And honestly, I believe most of them are irrelevant and may even confuse our LLM. But you see, these are the results of one function call, for example. So this is the reflection. Step 3, search for the relevant information from the sources one by one. I have gathered the search results from various sources to check Lionel Messi's age. 1, Wikipedia. According to the search results from Sports Illustrated, Lionel Messi is approaching 38 years old as of 2025. This is correct. It has also included the source. I like this. I want to make sure it does the same thing for my subsequent executions as well, so maybe I should specify this in my system message. ESPN, specific details about his age were not present, but coverage of his recent achievements within his club, Inter Miami, confirms he's actively playing, fitting with the age range of mid to late 30s. Okay. 3, other sources like BBC Sports, Sky Sport, club profiles, no direct age. But additional verification shows he was born on June 24, 1987, making him 36 years old as of 2023. Okay. So I'll move forward to summarize the findings and generate a Markdown report. And I believe this is the Markdown report. And it has called the terminate function. Yes, done. And this is the task result object returned once all of the agent's operations is done. This is, what happens in AutoGen when you call the run stream method. It yields messages, and once we're done, it yields a task result containing the history of the chat. All of the messages so far. So it is somehow working, but it is not really efficient. I want to make it more efficient. First of all, as I saw here, let's double check again. I guess it had searched for various resources at the same time in parallel. This may seem good, but it has its disadvantages as well. So let's make sure this is the case. Yes. So for example, you can see this is a function call. You're seeing it with this argument, Lionel Messi age 2023. And this is another function call with another query, Lionel Messi birth date. This is another function call. This is another one. So we have several function calls at the same time. And the problem with this is that, every function call returns the content of a web page. And as I just said, we have long web pages. And, if we want to compile several web pages at the same time simultaneously, this may be misleading for our LLM agent, or there might be irrelevant information in those HTML pages that might confuse our model. So I want to do this one at a time. We look for one HTML page, one resource, we summarize it. I mean, by summarizing, not just summarizing it blindly, we just look for the relevant information that is relevant to our query. We'll keep that, and then we'll go on to the next resource. This way, I believe it has the least amount of confusion for our LLM, but yet it has another problem. So basically, what an assistant agent does by default in AutoGen, you see in an assistant agent, in every step, it has a context, which is the whole history of its past. So what I mean by this is that in every message, when the agent is calling the LLM inside itself to generate the text, it provides the whole history to the LLM as well. So for example, if we had, let's say 5 or 10 messages before our current time step, AutoGen will provide all of those 5 or 10 messages to the LLM so that the LLM has access to our history and can better generate the output. While this might be good for many small size projects, but if we want to look for example, in this project, if you want to look for more sources, let's say instead of 5, if you want to look for 10 or 50 or even more than that websites and sources, the problem will be that we will have as many long web pages as the number of sources. So this is a real challenge and we want to avoid it. But what can we do? Well, an assistant agent in AutoGen has another argument called model context. Let me show you this model context in their documentation. AutoGen documentation. Agent chat and assistant agent, agents, and assistant agent. Yeah, that's what I was looking for. Okay, this is the assistant agent class, and where's the model context? Yeah, this is the model context. It should be an object of chat completion context class. So what do we mean by model context? This is what I just said. So by model context, we mean what context are we providing for the model before it generates something for us. So by default, the model context in AutoGen is all of the previous chats, all of the history. And this is good if we have, a limited amount of messages and the messages aren't long. But if we have, for example, several HTML pages, then we're in trouble. We don't want to keep all of the text content of those pages, which contain many irrelevant information as well and can be quite misleading for our agent. So we need to provide a better model context for our agent. And as I've said this many times before, this is a very important skill if you want to be a professional developer. This is a very important skill to be able to read the documentations or go through the GitHub codes and figure out the details and the answers to your questions. So just as a practice, let's go and visit their GitHub and see the code for the assistant agent. Okay, this is the code for the assistant agent. And okay, let's go down. Okay. Before this, I remember I've seen a diagram explaining the steps in an assistant agent. Yeah, it's this one. Let me show you this diagram. Once you have a new message, it will add the new message to the context, to the model context. Then if you have some memory, which is another argument you can provide for your assistant agent. It will also update the context, the model context based on the memory. And then it will ping the model client, the LLM, and it will provide the model context for the LLM. And once the LLM generates the output, it will also update the model context with that. And if you have a tool call, or maybe you have handoff, which is for a specific kind of teams in AutoGen, and also if you have reflect on tool use, it will handle those operations as well. And these are the steps being done in an assistant agent. So we have exactly these steps. We can see them here. For example, you can see this is the constructor for the assistant agent. It is initializing different variables that are necessary for the assistant agent. And then we have this onMessage or onMessage stream, which is the main function that is used to generate the output of the agent. And here you can see these steps. Step 1, adding the new user or handoff messages to the model context. Step 2, updating model context with any relevant memory, just like we saw in the diagram. Step 3, to generate a message ID. Step 4, to run the first inference. This is a step that pings the LLM and gets the output from the LLM. And we can see it has used a self.callLLM function. We can also look for this one to see what is provided for the LLM. So inside this coroutine, this call LLM, we can see it has the model client, whether it wants to also stream the model client response or not, the system message, the model context, and so on and so forth. And here's what we should focus on. It has gathered all the messages. And how it has done this, it has called this coroutine get messages from the model context. So we have a model context object. It has a coroutine get messages. It has called it, and it has all the messages from the model context in all messages. And then it has provided the system message plus all messages as the context for the LLM. We can see this is the LLM messages. So as you can see here, we need to provide a custom model context that doesn't include the previous web pages or the previous tool called results. At each time step, we just want to keep the latest tool called result from which we should, look for relevant information. But let's say, for example, we're processing the 5th web page. Well, we don't need to keep the previous 4 web page content. So now I need to create a custom model context class that always keeps the latest tool call function. So now I need to create a custom model context class that always keeps the latest tool call result and always gets rid of the ones before the latest one. So let's take a look at model context classes in AutoGen to get a sense of how they work. So we need a chat completion context class, or a class that is a child of this one. You see, chat completion context, this is an abstract class, as you see. So all of the model contexts in AutoGen should be children of this class, should derive from this class. And by the way, the default model context class in AutoGen is this one, unbounded chat completion context. As the name is self-explanatory, it keeps all of the history and provides it to the LLM at every time step. So here we can see how to create a custom model context. For example, a reasoning model context. This is what we're seeing. It has it has been derived from unbounded chat completion context, because there are other coroutines and methods as well for serialization and for getting a config and saving the states of a model context. If you want to directly derive from this chat completion context, we should take care of all of them. But for example, unbounded chat completion context has done this for us. We can easily just derive from this, inherit from this one, and only override the get messages coroutine. So as you can see here, for example, the reasoning model context, it has overridden the get messages coroutine. And at the end of the day, this coroutine returns whatever context we want to provide for the LLM. So it's really worth spending some time on this, maybe a minute. So let's take a look at what it has done. Initially, it gets all of the messages from the superclass, which is this unbounded chat completion context. So this basically means the messages contain all of the history right now. Now we want to keep some of these messages and get rid of the rest. So initially we have an empty list called messages out. And for messages in all of the history, we check if this is a thought process, if this is a thought message. We set it to none. We don't want to include it. Since, because in many cases, the thought messages are so lengthy, so long, just like the HTML content we're dealing with right now. And then it appends the message without the thought to messages out, and it returns messages out in the end. So we should do somehow a similar thing. We should inherit from unbounded chat completion context. We should override the get messages, but inside these get messages, inside our get messages, we should always find out what is the last tool call message. We need to keep that, but we need to get rid of the previous tool call messages. And as you can see, this model context, this is a somehow more advanced topic in AutoGen, and it is inside the AutoGen core, not AutoGen agent chat. And the messages are of type LLM message. So we should find out how to differentiate between the text messages and the tool call messages in LLM message class. Okay, let's go back to the source code for call LLM. Let me see how it is using the LLM messages. So okay, previously we were here, so we're calling this, we're iterating over this generator, and once we have a new message, you see it is adding that message as an assistant message. So this is a type we should be looking for, assistant message. Let's go back here, and yes, this is assistant message. It has a content which can be either a string or a list of AutoGen core.underline_types.function call. Yes, this is what we should be looking for, function call. And I'm seeing some function execution result as well. So function execution result is of this type. We should also take care of this one. So I guess we should look for assistant messages, and we should take a look at their content. If the content is a string, then we need to keep that message. But if it's a list of this type, we need to get rid of it and make sure we're not providing this as the context for the model. And how about this? I'm not sure. Let's check the source. Okay, content is a string, and okay, so we need to figure the details out inside our program. Let's get back to our example of having a custom model context. So first of all, I need to import this unbounded chat completion context. So let's get back here from AutoGen core.model context, import unbounded chat completion context. And now I need to create my custom class. So a class, let's call it MH context. MH is my initials, okay? Initials for my first name. So it derives from unbounded chat completion context. And I only need to override its get messages, as we can see here. So async def get messages, no arguments, and just like what we're seeing here, I can initially get all of the messages from the superclass, from the unbounded chat completion context. Now I have all of them. Maybe one thing that I can do is that I can print out the message content type, and if it's a list, I can print out the first element of that list, the type of the first element of that list, to make sure what are the different types for different messages, for function requests and function results. So I can say for message in messages, if message dot content, I need to check this one. If is instance message dot content and string, if this is a string, then maybe just forget about it or print string message. This is just for debugging purpose, so I will delete these print statements once we know exactly what we're looking for. And else, this means that this is not a string and is a list. I can say print list and type of message that content the 0 index. So I believe we're good to go now. And just to be able to clearly see these print statements, I can add a bunch of hashes, and now I also need to set this model context to MH context. And let's see. Okay, well, this makes sense. Our first message is a string message, so it's fine. Then we have a function call. Yes, you can see. Then the message.content will be a list, and its first element type is a function call. This is what we were expecting from reading the documentation. And now you can see, once we have the result, the first element of that list, msg.content list, will be of type function execution result. So we should check for these two types. We should keep the last element of each of these types and get rid of the rest. So this is what I need to do. First of all, let me import these classes from AutoGen core.underline_types. Since it has an underline at the beginning, VS Code will not suggest it for me. I need to type everything manually. So from AutoGen core.types, import function call. And again, from AutoGen core.types, you see no recommendation of types. Import, I need to say from AutoGen core.models.types, import function call result. Yeah. Okay. Now, instead of iterating over all of the messages like this, I can easily keep, store the indices of the messages of type function call in a separate list, and the indices of the messages of function execution result in another one, and keep the last element of each list and pop out all of the remaining elements in those two lists. So I can say indices of function call, and for this I will say I for I and message in enumerate message if the message.content is a list and its first element is a function call object. Yeah, like this. And I can do the same for function called results, function execution results. Let's say func result. That would be exactly the same, except the last type that we should check. And just to make sure everything is all right, I can print them. So let's clear the terminal and run it. So I expect to see more indices gradually once the messages are going forward. You see, initially we have just one tool call, so the indices of the function calls is just 1, and the indices of function results is 2. Then after the second tool call, you see we have 4 and 5 because the reflection was 3, then we have 4, 5, and then we have 8 and 9. Okay, so you see we have something here. Now what I need to do is that I need to forget about the last element of each of these lists and get rid of whatever is remaining there. So let's say indices is indices for function call, all of them except the last one, plus indices of function results, all of them except the last one. And I need to sort these as well. Because, if I want, let's say I have a bunch of indices and I want to pop those indices from a list. So the correct way of doing that is that I need to sort these indices and come from the last one and pop sequentially from the last to the first. If I don't do it this way, for example, let's assume I want to do it from the beginning to the end. Let's say I want to remove index 2, 4, and 6. If I first remove or pop out the index 2, then all of the remaining elements get shifted 1 to the left. So the old index 4 will now be index 3. The old index 5 will now be, the old index 6 will be currently index 5. So I need to take care of those, shifts, and this is really a headache. So what instead I can do is that I can pop out from the very last element. So if I initially remove index 6, 2 and 4 are still there. Then I can come to the index 4 and pop out that one. Everything is fine yet. And then I can go to index 2 and remove that one as well. So I need to sort these indices as well. And then I can easily say for I in reverse of indices, make sure I'm popping out from the last index. Then I can easily say, and I need to make a copy of my message because this is all of my history, and I need to copy these as let's say result. And to make sure I'm copying everything in the correct way, I will use the deep copy module in Python. From copy, import deep copy. Yeah. So this makes sure I'm copying all of the elements in the correct way. I encourage you to go and read about deep copy. For example, if you have a bunch of nested lists inside a list, and if you just easily copy the regular way, they will not be copied correctly. But if you use deep copy, it will make sure everything gets copied in the correct way. So for I in reverse of indices, I will pop out the ith element from result. And in the end, I will return result. Okay, this seems fine to me. Let's see if everything works. Let me run this agent.py once again. So at this stage, we're seeing all of the messages because that's how it is supposed to behave. It returns every message, but for the LLM under the hood, it only has the latest function called result and request, not the ones before the latest one. So let's see. This is our initial message. Our initial query is Lionel Messi, 25 years old on 2025. This is the plan, the step-by-step plan. And then we have a function call and a function execution result. And you see lots of redundant information. For example, 2014, 672 for Barcelona, 32 for Paris Saint-Germain, And this is a reflection. I found information about Lionel Messi's birthday. Lionel Messi was born on June 24, 1987. Now I will move to step 3. and check multiple sources. Okay, let's see. Again, another result. I'm interested in the reflections. Yeah. Based on the search results, he was consistently reported to have been born on June 24, 1987. And these are some sources that report this. So he will turn 38 in 2025. Now I will prepare the final report and conclude this check. And this should be the final report, yeah. Okay, so it seems working now. Just let me refine my instructions, my system message. You are a helpful assistant for news fact checking. You'll get some news or a statement and you need to check online. Once you get the input, you need to generate a step-by-step plan as your first message, like the following. Okay. Maybe I can be more specific now. Then you need to follow the plan. In each step, you should clearly state the current status and what are you gonna do next. Now let's be more specific. On step 2, you just need to list the sources without any tool call, and you can any tool call. On step 3, you can use the provided tools to search for information. Make sure to look for one source at a time. Once and reflect on the findings, stating relevant information before moving to the next source and calling tools for that. Yeah. And on step 4, make sure to generate a clear and concise markdown report summarizing the findings. At the end of the report, you should generate a table. I want a table. The rows will be, each row will be for a source and what we found from that source and some link to the specific page on that source. You should generate a table summarizing the sources table with these columns: source, claim, verdict, explanation, and link to specific page and link. Yeah. The link column should contain the URL of the specific page in the source. Yeah. Okay, let's see if things get better now. Okay, here's my step-by-step plan. Decide on search terms, and 2, decide on the sources. 3, search for the relevant information, and 4, okay, this is 4, summarize the findings and generate a markdown report. Okay, now we have some tool call. This is the result, the function execution result, and this is the reflection from the agent. From the search result, I found that Lionel Messi was born on this date. And next, I will move on to step 3 to verify, okay, across multiple sources. Signing on this one. Okay. Again, another tool call, another result, and this is another reflection. Again, you see another tool call. This is what I exactly meant, doing one tool call at a time, reflecting on it, and moving on. And this is another one. Okay. Okay, there was a timeout issue with one of the sources, okay? But given the evidence gathered from multiple credible sources, the birth date is confirmed. Now summarizing the findings, and we have a table. This table will be much more beautiful once we render it in Streamlit. Okay, this seems fine now. So let's develop the web application UI for this agent. It will be super simple. So I will call it app.py, and we need to import Streamlit as st, and also we need to import async.io, and we need to split this main coroutine into several coroutines. One, we need to split it into a function to do the configuration, and an async generator to orchestrate the agent. So let's call this config, and it doesn't need to be async because we're not awaiting anything. Oh, we are. Okay, so let's keep it as a coroutine. This is our config, and it should return a theme in the end. And now we will define another coroutine, or it is technically an async generator called Orchestrate. It gets a theme and a task. So we assume the task is provided as an argument. And let's define the main coroutine. Theme will be await config, and this will be the task. And instead of printing the message, we will yield it. And this is exactly what we should do. We should iterate over this orchestrate of theme and task and print each message. And we'll print a bunch of dashes to make sure we can easily see different messages. And just to make sure everything works well, because this agent.py should run and should be a standalone script by itself. Yeah, you see, it is working. Okay. Now we have this orchestrate and config. We can import them inside the app.py. So from agent import orchestrate and config. So I need a title, AI or news fact checking agent, something like this. And okay, now I need a chat container to render and display the chats here. So it will be an sc.container. And I need a chat input message, chat input. And if the user has entered any prompt or task or query, now I need to create the team and I need to orchestrate the team and display the messages. So I will define a coroutine here, async def run agent. Yeah, this is fine. And I will provide the team and the task. And before this one, I need to create an event loop and run async io.run and create the team config. And this will be the team. And now I will use this team inside the run agent. So I will iterate our different messages in orchestrate of team and task. And I need to check, as I already said, you see this run stream method that is being called inside the orchestrate async generator, this run stream, it yields messages. And once we're done with the messages, as the last element, it returns a task result object. So I don't want to, display the task result object. So I can check if it's not a task result, then I will show that message. So from AutoGen agent chat.base import task result. And now I can say if this is not a task result, then now I need to check if the message is from the user. I need to display it with a human-like avatar. If it is from the agent, I will display it with an AI avatar. So if the message that source is user, then I can say with sc.chat message from the user, this is a predefined value. It doesn't have any connection to my AutoGen, user. So sc.markdown message.content. And then I need to, and else, if this is coming from the agent, similarly with sc.chat message, and I want to display the avatar for assistant. This is also predefined in Streamlit, and I will render it as, I'll render the message.content as markdown. And I guess this is fine. So let's just run this coroutine as well. So, and just for a better gesture, let's have a spinner object. And once we're done, I will show a success element. So this, I guess this will be working. Let's just check. Streamlit run app.py. And let's ask the same question. Is Lionel Messi 25 years old on 2025? Let's see what happens. Okay, you see, this is the message from the user. This is the message from the AI agent. Here's my step-by-step plan. And yeah, we have some ugly function call messages. I will display these with an expander object next. And this is the summary table in the end. Link Instagram. Well, this is strange. Lionel Messi was born on June 24, 1987. I calculated it to be this one. And these are the sources. So I believe something's wrong with this one. Okay. We need to modify our system message to make sure it behaves the way we like. And also we need to display this function call messages inside an SC expander just to be more beautiful. So I can check if these are text messages, then I will render them this way. Otherwise, it means that they're function calls. So I will render them as an SD expander object. So let me also import from AutoGen agent chat.messages, import text message. And I will check if message is an instant of text message, then render it this way. Otherwise, use an SC expander and call it a tool call. sd.markdown the whole message. Okay. Or message.content again. And oh, one thing I forgot, I'll wrap all of these inside the chat container. I want to make sure all of the messages are there. Of course, right now we're safe, but if there are more elements inside our Streamlit application, then things will be messy. And let me make sure it searches all of the sources. On step 3, you can use the provided tools to search for the information. Make sure to look for one source at a time and reflect on the findings, setting relevant information before moving to the next source and calling things for that. Make sure you look for all of the sources before proceeding to step 4. Okay. Let's see. And although I'm not looking to develop a product right now, it's just an illustration and a showcase, but this is really dull. I can, add some emojis to the title at least. Is Lionel Messi 25 years old in 2025? Okay. We have different tool calls. This is from Wikipedia. This is from ESPN. This is from BBC, okay. 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 Has it generated the report? Oh, the report is also in a tool call. This is strange. It shouldn't be like this, but at least you see we have something. We have some clean report. So to verify the claim about Lil Mess's age in 2025, I examined multiple sources for confirmation. This is a summary of findings. For each resource, we can see what it has found, and then we have this table: source, the claim, verdict, which is false, and the explanation. Okay. So this sounds okay, but I should figure out why do we have the final message as a tool call. This is strange. So maybe I can debug this as well. So for each message, let me also print its type, print type of the message. And the message.content, type of it, and print the message, and print a bunch of dashes just to make sure we can easily see different messages. And by the way, let me add some emojis to this title. Add some emojis, some relevant emojis to decorate it. Yeah, this is good. So, and let me copy the task. Yeah, this looks much better. And let me ask the question. And at the same time, let's have a look at the terminal. Text message, tool called request event. Okay. Let's see what happened. It had just one tool call. This is ridiculous. Okay, it has searched for different tools at the same time. Yeah, I don't like this. And, if it searches for different sources at the same time, the problem is that based on our custom model context class, it only keeps the last one. It somehow, stores them in a list and only keeps the last one. So we don't like this. And that's why you see it has said it didn't get any relevant information from these sources, and only it got from one of them, which is Wikipedia, for example. So we need to make sure it doesn't call several tools at the same time. So maybe I can specify this inside the agent.text. So never call several tools at the same time. Let's see if this works or not. Yes. This is from Wikipedia. This is from ESPN. Goal.com. Yeah. Okay. So this is exactly what I was planning for. So you see, we're looking for several tools. We're looking for several sources, one at a time. And in the end, we have a report and we have some links. And just to make sure everything's all right, let me check one of the links, for example, the Wikipedia. Yeah. Okay, cool. And I still haven't figured out why the previous summary report was inside an sc.expander. I'm not sure about the main reason. One guess is that, obviously based on our code, let me show the code. Obviously based on the code, you see, if it was a text message, it would have been rendered as an ordinary chat message. So it wasn't of this type, text message. Maybe it was from another type. Sometimes it stores it as a thought message or something like that. I just want to make sure this problem doesn't occur again without digging into the problem. So one thing I can do is that I can, instead of checking it this way, instead of looking if it's text message, do this, else use an expander, I can check if it's a function tool call, then do this, use an expander, else use a chat message for that. And we can see, for a function tool call, the type of class is tool called request event and tool execution result. Those are the two types. Let me show you, function execution result and tool call execution event. So I need to check for those two classes. From AutoGen agent chat.messages, import tool call execution event and tool call request event. Yeah, these two. Or yeah, this is it. Tool call execution event and tool call request event, these two. So I can check. Instead of doing it this way, I can use this for else, and I can move this expander for my if, and in my if I can check if this is a tool called request event or this is a tool call execution event, then use expander, otherwise use markdown. And let me ask again, is Lionel Messi 25 years old on 2025? And as you see, for example, this time from Wikipedia, it didn't get the birth date. Well, as you see from the previous executions, the problem is not with our code. Sometimes Tavily doesn't return the appropriate result. It happens sometimes. Sometimes I've experienced this. Their server gets timed out and they return nothing. So this is the main problem, I guess, for now. And oh, we have the context length problem. Wow. This model's maximum context length is this amount of tokens. However, your message contains way more. Yeah, this is the problem with Tavily. Sometimes it returns, the whole HTML, a lot of information, although we've tried to tackle this with our custom context class, but still we're suffering from it. So let's run it once again and hope that Tavily returns a reasonable result for us. Okay, now we have this one. Is Lionel Messi 25 years old on 2025? Here's the step-by-step plan. Again, we don't have a reasonable result from Wikipedia. Okay, let's see. Okay. The results seem strange. Let's see what happened. Here's the tool call for Lionel Messi birthday. And this is a general search, okay? No specific domain. Well, for example, here, can we see a birth date of Messi? I cannot see. So maybe it is right and our initial judgment wasn't fair about it. Let's see. Again, no birth date here as well. And how about this one? It's strange. Yeah, it seemed none of these had the birth date. But so maybe it was right in some sense, because none of these returned results were containing the birth date. But this is strange. Let me use another LLM. Maybe, GPT-4.0 isn't using the best terms for search. So instead of GPT-4.0, let me use, for example, 4.1. I believe that will be a better LLM. Although I haven't used it so far. So let's hope for the best. So, is Lionel Messi 25 years old into 2025? the tool call. Yeah. Yes, so we have a bunch of tool calls. So let's see, for example, the ESPN search result. It mentions that Messi turns 38 years old. Yeah, and some information from BBC. Do not give his birth date directly. So yes, there's no birth date here as returned by Tavily. And also here, let's see, for goal. Yeah. So at the end, we have different responses. And you see in the report, BBC Sport does not state, goal.com notes that he's being 38 years old. For example, Britannica Encyclopedia, it says the birth date is this one. So yeah, we have a somehow comprehensive report now. And just to make sure it is working correctly, forgive me for this, but let's try it once more. I want to make sure the program it runs flawlessly. Was Messi born in 2000? Yeah, let's see what we get. Yeah, from the first search, it says that he was born on 1987. And it's strange, the search with the Wikipedia return details about his career, but not exact birth date. This is a search from Wikipedia. Yeah, this is Tavily's fault, you know. Let's see our tool call. Yeah, Lionel Messi birth date. So we can see Tavily wasn't really effective here. I've used it in a previous project. It was really good, that project, but I don't know, maybe it has get worse. So yeah, you see from various resources it has found that he was born on 1987. Okay then, so we've experienced a real project development and agentic AI project development. We've run into errors and we've figured out how to fix those errors. I hope you've enjoyed this video, and of course don't forget to give me your suggestions for the next videos. If you have any interesting idea in mind, feel free to drop a comment, and I'll make sure to record videos on the interesting comments, interesting suggestions. So I hope you enjoyed this video, and if you really want to learn how to develop an agentic AI project effectively, this is what you need to do. You need to start from scratch, you need to write every line of code, and you need to run into errors and figure out how to solve them. So I strongly encourage you, please do it yourself now. You've watched this video. If you're here, it means that you watched the whole video. Congratulations, now you have an idea what to do, so go ahead and do it yourself. I hope you enjoyed this video. Until the next one, take care.